Hi, I am Syed on Mass Online. Today's topic is Perel equation of a polar curve. In the previous video also we have taken the same topic. We have done few examples based on the Perel equation. So we'll try to continue with few more problems in this video. So the first question is find the Perel equation of the curve r power of m is equals to a power of m into cos of m theta plus sine of m theta. Let us consider the curve r power of m is equals to a power of m into cos of m theta plus sine of m theta. So let us take log on both the sides. So we get log of r power of m is equals to, it is log of a power of m into cos of m theta plus sine of m theta. Or further, this can be written as log of a power of m plus log of cos of m theta plus sine of m theta. Or further, log a power of m can be written as m log of a, and the second term will be as it is, log of cos of m theta plus sine of m theta. Left hand side also, this log r power of m can be written as m log of r. Now let us try to differentiate this with respect to theta. Differentiate with respect to theta. So it is m times of log of r differentiation will be 1 by r into dr by d theta. M log a is a constant, its derivative will be 0 plus log differentiation will be 1 by, it is cos of m theta plus sine of m theta. Further differentiation of this cos m theta will be minus sine of m theta into m plus differentiation of sine m theta will be cos of m theta into m. Further, we can simplify this one. M as it is 1 by r dr by d theta is nothing but cot of phi, that is equals to. So here you can see that m is common, so I'll take m common outside, and then I'll first write down the positive value cos m theta, then the negative value minus sine of m theta is whole divided by, you have cos of m theta plus sine of m theta. Cancel out this value of m. Since you have on the left hand side cot, right hand side also you need to express that in the form of cot, or you can express it in the form of tan. So for that, what we'll try to do is, if you want to get tan on the right hand side, it should be in the form of sine by cos. So since you already have sine value, if I divide this by cos, then in that case I'll be getting tan. So it is better you divide by cos of m theta in the numerator as well as in the denominator. In the numerator and denominator. So this will be equals to, suppose if I am dividing the numerator by cos m theta, it is cos m theta divided by cos of m theta. Each of the term is divided by cos m theta minus sine of m theta divided by cos of m theta. It is whole divided by, denominator also you are having cos of m theta divided by cos of m theta plus sine of m theta divided by cos of m theta. We can cancel out this cos m theta in the numerator as well as in the denominator. So that will be equals to, it is 1 minus of sine by cos will be tan. So we'll be getting tan of m theta. It is whole divided by 1 plus, it is sine m theta divided by cos m theta will be nothing but tan of m theta. So this particular value, it is 1 minus tan theta divided by 1 plus tan theta, can be expressed as cot. So it is cot of pi by 4 plus m theta. The formula for 1 minus tan m theta divided by 1 plus tan m theta can be expressed as cot of pi by 4 plus m theta. A similar result I have shown in one of my previous video. You can watch that video to know how do we get 1 minus tan by 1 plus tan in terms of cot. So on the left hand side we have cot of 5. So therefore we get the value of phi to be equals to pi by 4 plus m theta. So now to express in the parallel equation, we have this relationship P is equals to R sine of phi. So just plug in the value of phi over here. It is sine of phi value will be pi by 4 plus m theta. So theta has to be eliminated from here. So keep R as it is. Now this is in the form of sine A plus B form. So we know this result, sine of A plus B. The standard formula is sine A cos B, sine A cos B plus cos A sin B. This is the standard formula. So let us try to take this formula over here. So in this case, we are having the value of A to be pi by 4 and the value of B is m theta. So let us use the formula here. It is sine of pi by 4 into cos of B. B value over here is m theta plus cos of pi by 4 into sine of m theta. That will be equals to R times of, we know the value of sine pi by 4. The sine 45 is 1 by root 2. There is 1 by root 2 into cos of m theta. And cos of pi by 4 or cos of 45 is also 1 by root 2 into sine of m theta. So 1 by root 2 is common. You can just take 1 by root 2 outside. You can write that as R by root of 2. So we are left out with cos of m theta plus sine of m theta. But still we are having this theta value. We need to eliminate this value of theta. So let us go back to the question and see, since we are having over here cos of m theta plus sine of m theta. So we can obtain this cos of m theta plus sine of m theta value from this result. So let us take this as equation number 1. I'll take this particular p value to be equation number 2. So we'll try to get from equation 1, we have the value of r power of m by, so r power of m is equals to a power of m is there. You just cross multiply, you will be getting a power of m, right? So you can just see that I've just cross multiplied this value of a power of m on the other side. It goes to the denominator. So right hand side we are left out with cos m theta plus sin m theta. So we have cos of m theta plus sin of m theta. So hence we have got the value of cos m theta plus sin m theta to be equals to r power of m by a power of m. So just try to plug in this value back in equation number 2. So substitute this value in equation number 2. So we'll be getting the value of p to be equals to r by root of 2 into cos m theta plus sin m theta value will be equals to r power of m by a power of m. So further, if you try to simplify this, r power of 1, r power of m. So r power of 1 plus m, or I can write it as m plus 1. and in the denominator we are having root 2 into a power of m. You can just cross multiply that value, so we'll be getting root 2 a power of m into p. That is the value you are having. So therefore we have got r power of m plus 1 to be equals to, it is root of 2 a power of m into p. You can see that this relationship does not contain theta. It contains only p and r. Therefore, this equation is called as the parallel equation of the given curve. Is the parallel equation of the given curve. Let us move on to the next question. The next question is, find the parallel equation of the curve L by R is equals to 1 plus e cos theta. So given the curve L by R is equals to 1 plus e cos theta. So we'll be taking log on both the sides. So we'll take log of L by R is equals to, it is log of 1 plus e cos of theta. So this will be equals to log of L minus log of R is equals to log of 1 plus e cos of theta. So let us try to differentiate this with respect to theta. So differentiate with respect to theta. Log L is a constant, its derivative will be 0. Log of R will be 1 by R into dr by d theta is equals to, log differentiation will be 1 by, it is 1 plus e cos of theta into this differentiation of e cos theta, e will be as it is, cos theta differentiation will be minus sine of theta. So further we can write minus 1 by r dr by d theta is cot of phi is equals to, it is minus e sine of theta divided by 1 plus e cos of theta. Cancel out this negative sign from both the sides. So since you're having e in the numerator as well as e in the denominator, it is not possible for us to express it in the form of cot or tan. So therefore, we just try to keep this expression as it is and go for the parallel equation. So we have the value of p to be equals to, it is r sine of phi. So here phi cannot be obtained independently. Therefore, this sine phi value has to be expressed in the form of cot. So we'll try to express this sine phi in terms of cot. So let me take this as say equation number 1. So since I need to express this sine in the form of cot, so first I'll try to square on both the sides. So squaring on both the sides, squaring on both sides, so we'll be getting the value of p square to be equals to, it is r square sine square of phi. This will be equals to, so I'll try to take the reciprocal. So let us take the reciprocal over here on both the sides. So we are taking the reciprocal. If I take the reciprocal, it becomes 1 by p square is equals to, so I'm taking the reciprocal on the right hand side, it will be 1 by r square sine square of phi. So 1 by r square, we'll keep it as it is. But we know 1 by sine is cosecant. So therefore 1 by sine square will be cosecant square of phi. But we have to express in the form of cot. So I can write this cosecant to be equals to 1 plus cot square of phi. So initially we started with sine phi value and now we have obtained the cot value. So we know the value of cot of phi from equation number 1 over here. So we'll just try to plug in that cot phi as e sine theta by 1 plus e cos theta. So this will be equals to 1 by r square into 1 plus. So the value of cot of phi will be e sine of theta divided by 1 plus e cos of theta This is cot phi value, and we need to square this one, whole square, cot square of phi. So this will be equals to 1 by r square into, that is 1 plus. So let us square both the numerator as well as the denominator. You'll be getting e square sine square of theta divided by, it is 1 plus e cos of theta whole square. So since the value of theta has to be eliminated from here, so let us try to get the value of theta from the given question. So let us take this as a equation number 2. So from the question we'll try to get. So from the question we have, what is the question you have? L by R is equals to, it is 1 plus E cos of theta. So let us try to get it over here. So you can see here you have 1 plus E cos of theta. So that can be replaced directly by L by R because you are having 1 plus E cos of theta. So this denominator can just be replaced by L by R. Now we have to get this value, E square sine square of theta. So let us try to express this cos theta in terms of sine square of theta. So L by R as it is, let us take this plus 1 on the other side becomes minus of 1 is equals to E cos of theta. But I need to express this cos theta in terms of sine square. Therefore, first let us square this value. So squaring on both the sides. Squaring on both sides. So we'll be getting L by R minus of 1 whole square is equals to, you have to square it, it becomes E square cos square of theta. E square cos square of theta. But I can express this in terms of 1 minus sine square of theta will be cos square of theta. 1 minus sine square theta is cos square theta. So I've expressed this in the form of sine square, but I have to get it as E square sine square. So multiply this E square inside, E square into 1 will be E square minus, it is E square sine square of theta. But I want plus E square sine square theta. So let us take this negative sign on the left hand side. So it becomes plus E square sine square of theta is equals to, on the right hand side you have E square. So send this left hand side on the right hand side. You have minus of L by R minus of 1 and it is squared. So now the numerator value is also obtained. E square sine square theta is E square minus L by R minus 1 whole square. If we substitute in equation number 2, so this is your equation number 2 that we have over here. So we need to just plug in the values over here. So we have obtained this E square sine square of theta. That value I have to plug in over here in the numerator, right? And the denominator value also you have over here. So let me take this denominator value over here as equation number 3. The numerator value will take it as equation number 4. So we need to substitute this equation number 3 as well as equation number 4 back in equation number 2. So equation 2, the left hand side value that we have is 1 by p square is equals to 1 by r square times of, it is 1 plus, the numerator value is E square sine square of theta, which is nothing but equation number 4, E square minus L by R minus of 1 whole square. It is whole divided by, the denominator value that we have is 1 plus E cos theta, which is given by equation number 3. So 1 plus E cos of theta is given by L by R. It is L by R whole square. So let me try to multiply this 1 by R square inside. 1 by R square into 1 will be 1 by R square plus, multiply this 1 by R square with the whole of the second term. So this L by R whole square in the denominator, if I take it in the numerator, becomes R square by L square. So times of, you are having over here this E square as it is minus, it is in the form of A minus B whole square. You can expand this one. It is L by R whole square, that is A square plus B square will be 1 minus 2 times of AB will be 2 times of L by R. Or further, if you try to simplify this one, this value of R square will cancel out. That will be equals to 1 by R square plus, so we left out here with 1 by L square, Let us try to simplify this one. This is e square minus. So let me multiply this negative sign inside. It becomes L square by R square. Then minus sign I'm multiplying inside. It becomes minus of 1. Then minus of minus will become plus 2L by R. Or further this can be written as 1 by R square plus multiply this 1 by L square inside. You'll be getting E square by L square minus of, you can see in second term L square will cancel out. You'll be left out only with 1 by R square. Then minus of 1 by L square. Then plus 1 by L square is multiplied by, it is 2L by R. One value of L will cancel out over here. Plus 1 by R square minus 1 by R square will cancel out. We are left out with E square by L square minus of 1 by L square. It is plus 2 by LR. Or further, if you try to simplify this one by taking the LCM as L square, we will be getting the expression to be equals E square minus of 1 plus it is 2 by LR. So hence we have got the parallel equation. So this is the parallel equation of the given curve. That's the parallel equation of the given curve. So that's all I have for today. Thank you.